In this unit, we're going to focus on algebra. And algebra uses symbols or letters to represent unknowns, which allows us to model problems and solve equations. So one thing that's important to know, a term, if you will, is the term. A term is a product of a number, a numerical coefficient, and or letters, which are variables. Okay, so for example, 3x would be a term, 2y would be a term, and I can even have more than one variable. 3xy squared is also a term. We have some different types of polynomials. A special case is a monomial, which is an expression with one term. The three that I listed up there are all monomials. A binomial is an expression with two terms, something like 3x plus 2y. A trinomial is an expression with three terms, which would be like 3x squared plus 2x plus 7 is a trinomial. And then a polynomial is just an expression with really more than three terms. Anything less, and then you should call it by its specific name, a monomial, a binomial, or a trinomial. Like terms are terms with the same variable and the same exponent. If terms are like, we can actually add them together. So here we've got 3m plus 2m. Together they make 5m. So if you think of the m as apples, this first term says that we have 3 apples. The second term says that we have 2 apples. When we add those together, we get a total of 5 apples. In our second example, we have 2m squared plus 1m squared. When we add those together, we have 3m squared. So if the m was apples, the m squared might be bananas. So then we have 2 bananas plus 1 banana equals 3 bananas. In our third example here, we have 2m plus m squared. M is an apple. M squared is different because the exponent is different. This would be like a banana. When we add those together, we still have 2 apples and 1 banana. They're not like, you can't combine them. In the next example, we're going to state whether the following are like terms or unlike terms. Here I have 8x minus 2x. My variable is the same and my exponent is the same. These are like. In my second example here, I have m squared n cubed and then 10m squared n cubed. The variable is the same and the exponent is the same. So these are also like terms. In my third example, I have x to the 4, y to the 5, y to the 5, x to the 4. My variables are the same, x and y, and my exponents are the same, x to the 4, y to the 4. So these are also like. Here in D, we have 14p squared q and then 3pq squared. Our variables are the same, but the exponents are different. The first one has p squared. The second one only has p to the exponent 1. That means that these terms are unlike. In our third example, we have 5x minus 11. The first term has an x. The second term does not. That automatically makes them unlike. We can't combine them together. When you are working with like terms, you can add or subtract them by adding or subtracting the coefficients, which is the number, and you keep the variables and the exponents the same. So in our first example, we have 3x plus 4x. My variable is going to stay the same, and I'm going to add my coefficients together to get 7x. The next one, I have minus 7y plus 10y. My variable is going to stay the same, and I'm going to add my coefficients together following the integer rules. Minus 7 plus 10 is 3y. Example C, minus d minus 5d. I've got like terms. I'm going to keep my variable the same and add my coefficients together using integer rules. Minus 1 minus 5, that's going to give me minus 6. Here, now I've got 3 terms, but they all still have an m, so I can add them together. My variable is going to stay the same, and I'm going to add my numerical coefficients using my integer rules. 11 minus 2 is 9. 9 plus 3 is 12. In E, I have 4 terms here. I have 2 terms with a p, and then I have 2 terms that have an m in it. So I'm going to combine my m terms first. My variable is the same, and I'm going to add those numerical coefficients together. So 4m. Then I'm going to combine the p terms. So my variable is going to stay the same, and I'm going to add those numerical coefficients together. So 8 minus 7, which is going to give me plus 1p. In example F, I have lots of things here to put together. So I'm going to start off by underlining my x's, including the sign in front, because that tells me how I'm going to combine the coefficients. I'm going to put a box around my y's. And then I'm going to put a circle around my numbers. So the first thing that I'm going to combine is my x's. I have 4x plus 1x. So my variable is going to stay the same, and I'm going to add my numerical coefficients together. 4 plus 1, which gives me 5x. The next thing I'm going to do is my y's. So my variable is going to stay the same, and I'm going to add my numerical coefficients together. Minus 7 plus 7, which gives me 0y, which I can eliminate. And then my final one is I'm going to add my numbers together. 3 minus 6 is minus 3. So then my final answer is 5x minus 3. Example G, I have x squared and x squared. So my variable is going to stay the same, and I'm going to add my numerical coefficients. So 11 plus 5 is going to give me 16x squared. My last example here, a little bit more complicated. I'm going to do it the same way I did example E and F by grouping my like terms. So the first one I'm going to do is 2ab, and I see I have another ab term right here. Same variables, same exponents. The next one I have is b squared. So I have a b squared here, and then I have a b squared on the end. My last one is a number that is just by itself. And now I can start to combine my terms. So I'm going to start with my ABs. My variable is going to stay the same, and I'm going to add my numerical coefficients. So 2 plus 1 gives me 3ab. And then I'm going to do my b squareds. So my variable is going to stay the same, and then I'm going to add my numerical coefficients together. So minus 5 minus 7 gives me minus 12b squared. The last one is my number. That's not like the other terms, so I'm going to write it on its own. And then finally, I am going to put the term with the highest exponent at the front of my expression. The last thing I can do with like terms is actually write a simplified expression for the perimeter. And so here, everything that has one line is represented by n. Everything that has 2 lines is represented by 2m. And I don't know what the bottom is, but I do know that this is 2m. And this is 2m. and this must be 2m, which means that in total, my length down here must be 6m, 2m plus 2m plus 2m. So let's fill in the perimeter. I'm going to start with this side here. So I have n, then I'm going to do this side, plus 6m, plus n again, plus 2m, plus n, plus 2m, plus n, and finally all the way back, plus 2m. So now I'm going to add those all together. I'm going to group my n's. I've got 1, 2, 3, 4. So 4 n's. And then I'm going to group my m's together. So 6m plus 2m plus 2m plus 2m. So I've got 2, 4, 6, and 6 is 12m. The last thing that I want to do is make sure I've written my variables in alphabetical order. So 12m plus 4n. That would be my simplified expression for the perimeter of that shape. The last thing that we're just going to review is simplifying. We've done this before with substitution, where we replace a variable with a number, but now I'm going to give you an expression that you can collect like terms in first. So I'm going to underline all my terms that have an x. I've got 3 of them. And then I'll circle all my terms that have a number, because those terms are like too. Now I'm going to combine my x's. So my variable is going to stay the same. And I'm going to add all my numerical coefficients together. So minus 4 plus 3 minus 5 is going to give me minus 6x. And then I'm going to add my numbers together. So 13 minus 6 plus 8 would be, let's see, minus 6 plus 8 is 2. So that would give me 15. And this is going to be my simplified expression here. So simplified. And now I'm going to evaluate by substituting in x is equal to 3. So right here. So I've got minus 6 x plus 15. And I'm going to replace that x with a 3. So I'm just using red so that you can see where that 3 goes. This is my evaluating stage. And now I've got minus 18 plus 15 is equal to minus 3. This is my evaluated expression after I have simplified, substituted, and then evaluated.